Okay students, let us try to solve this question. It goes like, you are having neon gas generally used in the signboard, and if it emits strongly at 616 nanometers, you need to calculate certain things. Out of them, the first one is the frequency of emission, frequency, that is nu. Okay, then second, you need to calculate distance traveled by this radiation in 30 seconds. Time is given to you. Thirdly, you need to find out the energy of quanta E. And lastly, you also have to find out number of quanta present if it produces 2 joules of energy. Okay, let us try to solve this step by step. Fine. So for A, you are asked to find out the frequency. We know that frequency nu can be written with formula nu is equal to c by lambda. Here c is nothing but speed of light, which has got a value 3 into 10 to the power of 8 meter per second, and lambda is given to you as 616 nanometers. Okay, so we can take this nanometers into meters like this. 616 into 10 to the power of minus 9 meters, because 1 nano is 10 to the power of minus 9. Now see that on calculating this, when you divide 3 by 616, you will get 0.00487 into 10 to the power of 8, and 10 to the power of minus 9, which you have in the denominator, will be going in the numerator with plus 9. So you add. So you will be here left over with 0.00487 into 10 to the power of 17. Fine. Now you can shift this decimal point between 4 and 8 towards right. So you can write it as 4.87 into 10 to the power of 17 into, as we have shifted the decimal point towards right side with 3 digits, 1, 2, 3. So we write 10 to the power of minus 3. So you will end up with answer as 4.87 into 10 to the power of 14. And for units, you can see that you can cancel off meter, and you will be left over with the unit, that is your per second, which is the unit of your frequency. Okay. Now the second question is here, distance traveled, this one. So let us solve this. It is distance traveled by this radiation. Fine. So again, for that, we know that distance traveled, that is d, can be written as velocity of light, okay, into time. So now let us try to solve the distance. Distance will be equal to velocity of light, we know, will be 3 into 10 to the power of 8 meter per second, and time here you can see in the question is given to you as 30 seconds. So we can see that 30 into 3 will give you 90 into 10 to the power of 8. Here second and second will be getting cancelled off, so the unit you will be left over will be meters. Okay, or you can write this as 9 into 10 to the power of 9 meters. So that is your second part done with the distance traveled. Now let us talk about the third one. Here see, they ask energy of quantum. Okay, so we need to find out the energy. Now third part is, we need to find out the energy E, and for which we are very well aware with the formula hc by lambda, where your h is having a value 6.626 into 10 to the power of minus 34 joule second, into c is 3 into 10 to the power of 8 meter per second. Okay, divided by lambda. You know that here in the previous part we have used lambda as 616 nanometer. So it is 616. Let us take it in the meter. So we write minus 9 meter. Now calculate this. You multiply 6.626 with 3. You will get 19.878 and try to find out the value for 10 to the power of minus 34 into 10 to the power of 8. We add the powers of 10. So we have minus 34 plus 8. Okay. And in the denominator we have 10 to the power of minus 9. So here in the denominator we are having 616. Now we divide 19.878 by 616, you will get 0.0322, and here you will get 10 to the power of minus 34. You are having plus 8, and when this denominator 10 to the power of minus 9 comes in the numerator, 9 can be written with plus 9. So here you will have 0322 into 10 to the power of, you can see you can add 8 plus 9, it would be 17 minus 34, you will get minus 17 here. Now to write it in proper significant forms, you can write 3.22 into 10 to the power of minus 17 and into 10 to the power of minus 2 is because we have shifted 2 digits. So finally the answer of energy would be 3.22 into 10 to the power of minus 19, and the unit would be joules, is because you can see that here this second will be getting cancelled and meter will be getting cancelled. So that was your third part of the question, energy of quantum. Now the last one is number of quanta present if it produces 2 joules of energy, that we need to calculate. So let us try to solve for that D part, and that is number of, you need to calculate number of quanta. Let us take that as N, which will be nothing but the total energy which you have just now found above divided by 1 quantum energy. Okay, 1 quantum energy you have just now found out, and the total energy which is given to you here in the question is 2 joules. So see that you write 2 joules divided by the energy of 1 quanta which we have just now found out, 3.22 into 10 to the power of minus 19 joules. So here when you divide 2 by 3.22, you will get 0.619 into, you can take 19 above, so it will be plus 19. Joules will be getting cancelled off. You just need to find out the number of quanta. So finally the answer would be 6.19 into 10 to the power of 18, because we are shifting the decimal point towards right. So that would be the final answer. So you can see that the question was having 4 parts and we have solved them step by step like this. Thank you all.